On problems 4 through 8, our directions say to state if the polygons are similar, yes or no, and if they are similar, we're going to give the scale factor and the similarity statement. So if you say yes, they're similar, you have two more answers to give, the scale factor and the similarity statement. If you say they're no, they're not similar, then you're simply finished. Remember, when you give the scale factor, we use the variable k for scale factor, and we always write that ratio as the image over the original. So when we do not have prime notation telling us which one is the image, remember we determine the original one is the figure that is given first. And so since we read left to right and up to down, the very first one, when they're up and down, would be the one on top is the original, and then the one on the bottom is the image. When they are beside each other, left or right, the left one is the original, it's the one that's first, and then the right one is the image, original, image. So when I write my ratios, I'm going to start writing them as image over original, and then I'll have my scale factor if they end up being similar. When we go to write our ratios to see if the corresponding sides give me the same ratio each time, a common mistake is students will compare the 35 and the 18 because they're both the top segments of each quadrilateral. But on this quadrilateral, the 35 is the longest side, and on this quadrilateral, the 18 is the shortest side. So those are not corresponding sides. The longest of each will correspond, and the shortest of each will correspond if they're similar. So when I'm writing my ratios, again, I'm going to pick one of these side lengths from my image, since scale factor is image over original. So I'll pick the 18, which is the shortest side of my image. So I'm going to compare it to the shortest of my original, which is the 30. I want to know, is that equivalent to the image over original ratio for the longest sides? So 21 over 35. You have a couple of options of seeing if these are equivalent. One is to simply put these ratios as fractions in your calculator, 18 divided by 30, get that as a decimal, and then hit math enter to get the reduced form of that fraction. So 18/30 reduces to 3/5, since 6 goes into 18 3 times and into 30 5 times. 21/35 also reduces to 3/5, since 7 goes into 21 and into 35, into 21 3 times and into 35 5 times. The other thing you can do is check the cross products. If you multiply the numbers that are across from each other, 18 times 35 and 21 times 30, you'll find their products are exactly the same, which means they're equivalent as well. So since they have the correct reduced ratio for both of the comparisons, we know that these are similar figures. So our first answer, the yes or no answer, is yes. So now I'm going to write the scale factor, which, since I wrote my ratios as image over original, it's simply the reduced form of that ratio. And then I need to write the similarity statement. So when you're naming the first figure, if you'll just name that alphabetically, that would be A, B, C, D. Then when I go to name my similar figure, remember the corresponding sides have to be in the same position in the naming. So since A, B are the first letters of the naming of A, B, C, D, and A, B is the longest side of that quadrilateral, I have to name the first two letters of the longest side of the second quadrilateral. Since we have two of them, I have options. I can either name this segment as the first two letters or this segment as the first two letters. I just wouldn't want to name the shorter sides first. So I'm going to start off naming RS, since that's one of my longest sides. And then since I'm going RS, I'm going to continue in that same motion, and then T, and then Q. So that's one possibility. Since I started with RS, you could start with QT to TQ or SR, just as long as you're naming a longest side first. Let's look at number 5. Again, I'm going to write my ratios as image over original. So I'm going to pick a side of my image, such as 25. 25 is the second longest side of this figure. So I'm going to compare it to the second longest of the original, which would be the 20. Then I'm looking to see, is that equivalent to the 35 of the image is the longest side. So I'm going to compare it to the 28 of the original, which is the longest side. And then the only other measurement of the image is the 15.5. which would be compared to the 12.4. So again, we're wanting to know, are these equivalent? So when we reduce those ratios, we get 5/4, we get 5/4, and we get 5/4. So since we get the same ratio each time, our answer is, again, yes, these are similar. So my scale factor is that reduced ratio, which is 5/4. When I go to name my figures, I'm going to name the first one in alphabetical order, A, B, C, D. The symbol for similarity is one squiggly line. AB was the longest side, so my only options for the first two letters would be M and L in any order, ML or LM. I'm going to put LM, and then I'm going to continue naming that figure in that order. So LMJK would be the name of that figure. Let's look at number 6. In comparing the ratios, I'm going to pick a side of my image. So I'll pick the longest side, which is the 24, and I'll compare it to the longest side of the original, which is the 40. I'm wanting to know, is that equivalent to another ratio of the image? Well, let's get the next longest, which is 18, which would compare to the next longest of the original, the 29. And then the last sides would be image over original, 9.4 over 7.3. When we get the reduced form of those ratios, 24/40 reduces to 3/5. 18 over 29 does not reduce. So I already know, since these are not equivalent, it really doesn't matter what the last ratio simplifies to, which is 94 over 173, because none of those are equivalent. And so since those are not equivalent ratios, these figures are not similar. So that's the only answer we give. We don't give a scale factor because there's not one. We don't give the similarity statement because they're not similar. Let's look at number 7. I'm going to write my ratios, image over original. The 32 is the shortest side of my image. I'm going to compare it to the 7, the shortest side of my original. I want to know, is that equivalent to the longest side of the image over the longest side of the original? 32/7 does not reduce. 36/8 does. It reduces to 9/2. Since those are not equivalent, again, these figures are not similar. So I do not give a scale factor and do not write a similarity statement. Let's look at number 8. A side of my image, let's pick the 16, the shortest side. I'm going to compare to the shortest side of the original, the 5. I want to know, is that equivalent to the longest side of the image compared to the longest side of the original? 16/5 does not reduce. 24/6 reduces to 4. Again, those are not equivalent, so these figures are not similar. So that's simply our answer, no.